students, always keep these points in your mind and should always follow these. Like you should always wash your hand, not you. We should always wash your hand with the soap for about 20 seconds, or we can use a hand sanitizer, which is alcohol based, or always maintain a distance with the other person, which should be about 6 feet, and always wear a mask. Now we are going to revise. We are going the revision of chapters. The first chapter of physics, that is motion. The last chapter of physics, a sound, has been deleted from our syllabus. So we are going to revisions of the chapter from starting. That is from the chapter motion. In this chapter, what we have already studied, what we have learned. In this chapter, we have learned the motion, distance, displacement. So now let's start with the motion. You know the motion. What is the motion? For this term motion, you should first of all you should know the reference point. Reference point. What is a reference point? A reference point is, it can be an object, it can be a point. Suppose this is an object, a tree. It can be stationary. This reference point can be stationary. It can also be a moving object. So this is the tree, and suppose you are starting from here to move. You're starting from here to move, and after some time you are there at this point. So with reference to this tree, you are in motion because you have changed your position with respect to this tree. So this tree is called the reference point. So reference point is a fixed object. It can be a fixed object uh, through which you, uh, in comparison to with which object, you change your position. So motion, what is motion? If you change your position with respect to time, this is called the object is in motion. So first is the distance. In this chapter, we should know what is the distance and what is the displacement. What should be the difference? What are the difference between the distance and the displacement? Distance and displacement. You know the distance. Suppose you are starting from here and you move through a distance of like this, and now you are here. Okay, so this is the point A and this is point B, and you are moving in this path, and you travel through this path and reach to the point B. So actual distance traveled by you is called the distance. It means, suppose it is your home, and you start from your home and you move to a market. This is a market, and the path which is followed by you to move to the market is called the distance. This is the actual length of the path which is covered by you. And what is the displacement? Actual displacement is the shortest distance between the initial point and the final point. Suppose you start from here and you are now at this point B. So the minimum distance between the point A and a B, this is called the displacement. So actually displacement is the shortest distance between the between the initial and the final position of the moving body. And for the distance and displacement, we should know what are the scalar and the vector quantity. Scalar and vector. Scalar quantities are those which has only magnitude and no direction. Okay, so this is called the scalar quantity. And for the vector quantity has magnitude as well as direction. So first we should know what are the scalar and the vector quantity. Scalar quantity means like the distance. If you travel a distance, this is not important for you to explain about the direction of your motion. So in this case, suppose the distance between these 2 points is 2 meter. Actual path traveled by you is 2 meter. So the distance traveled by you is 2 meter. So we can say the distance is a scalar quantity because it has only the magnitude without any direction. You don't have to explain the direction of your path. So this is called the distance. This distance is a scalar quantity. And what is about the vector quantity? Vector quantities are those which has magnitude as well as direction. It means you are traveling through a path, and in this case, in case of displacement, you have to explain the direction of your motion. So if you are explaining the direction as well as the magnitude is the quantity. So here, this is the actual distance, which is 2 meter, and suppose from A to B the displacement is half meter. So you have to explain the direction also. It means in the direction of east the displacement is half meter. So displacement has a magnitude as well as direction. So the quantities which has magnitude as well as direction are called the vector quantity. That means displacement is a vector quantity. Okay, so distance is the actual path traveled by an object, moving object, and displacement is the shortest distance between the initial and the final position of the body. Distance is a scalar quantity and displacement is a vector quantity. Now, for example, you are moving in a circular path. You start from here, and after traveling a distance of it, distance can be anything like it can be it can be 3 meter, it can be 5 meter, anything. So you start from here this point A, and after moving in a circular path, again you reach as the point A. So now in this case, the distance traveled by you is the total length of this circle, or we can say it is the circumference of the circle. So now you start from here, and after traveling a certain distance, you reach to this point A. So in this case, the distance traveled by you is actually the circumference of the circle, which can be found by using the formula 2 pi r. 2 pi r is the circumference of the circle. So distance traveled by you is 2 pi r, that is the circumference of the circle. Okay. Now in case of displacement, now you start from here and again you reach this point A. So what is the shortest distance between the A and A? It is 0. It means for a moving body, distance cannot be 0. Object has to travel some distance if it is moving. But in case of displacement, displacement can be 0. In case when you start from a point and again you reach that to that point, it means the displacement is 0. So displacement can be 0, but the distance can't be 0 for a moving body. Suppose you are throwing a ball from here and you throw in upward direction. Again, after reaching to the maximum height, it again you catch this ball. So for this ball, the distance is the distance is actually suppose the height attained by this ball is h. So the distance is 2h, because this ball has to travel the path h plus h. But what is about the displacement? Displacement of this ball is 0. Since it start from here and again it reaches to this point again in your hand. So the displacement can be 0, but distance cannot be 0 for a moving body. Okay. Now again, if you start from here, this is the point A and you're traveling in a straight line. This is the point B. And again, you turn, you turn back and come to this point C. Okay. So it means suppose you travel a distance of 200 meter from A to B and again 100 meter from B to C. In case the distance traveled by you is 200 plus 100, that is 300 meter. This is the distance traveled by you. But what is about the displacement? Displacement is the shortest distance between the A and C. So this is 200 minus 100, 200 minus 100. Why minus? Because we know that displacement has magnitudes as well as direction. If we are representing this 200 with the positive sign, then the opposite direction we should have to represent with the negative sign. So in this case, the displacement is 100 meter. So it means displacement can be equal or it can be less than distance. In what case the distance and displacement are equal? Suppose the object is moving from here and it travel a distance up to the point B. So the distance traveled by the object is same AB, and the displacement is also same AB. So in case if an object is traveling in a straight line, you can say the distance and the displacement are equal. So distance and displacement can be equal. Otherwise, displacement can be less than the distance. But it cannot be, in any case, it cannot be more than distance. Okay. Now another example. Suppose you start from here, from the point A, and you travel through a distance of, I think, 200 meter. It can be any value to the point B. Now again, you turn back and come to, along this path, you come to the point C, which is 300 meter apart from the point B. Now, suppose you are representing this direction with the positive sign. So you have to represent this 300 meter by negative sign because it is the opposite direction of this one. So here the distance traveled by you is 200 plus 300, that is 500 meter. Again, in the case of this distance, you don't have to represent the direction, so it doesn't matter it is positive or it is negative. It means the overall distance traveled by you is 500 meter of sorry, it can be an any object, not you. So the distance traveled by is 500 meter. Now what is about the displacement? Displacement is 200 plus minus 300. It means it is minus 100 meter. Okay, it means the displacement can be negative. So I think it should be clear to you, that is, the displacement can be zero, but distance can't be zero for a moving body. Displacement can be less than or can be equal to the distance traveled, and distance is always equal or will be more than the displacement. And distance is always positive, but the displacement is always negative. And distance is a scalar quantity and displacement is a vector quantity. And what is distance? Distance is the actual path traveled by an object, moving object, and displacement is the shortest distance between the initial and the final position of the moving body. So these are some differences between the distance and the displacement. Now, um, now these are some questions of NCERT book. I think we should revise these questions also. Like the first question is, this is of page number 100. Questions: an object has moved through a distance. Can it have a zero displacement? Yes, it can have the zero displacement if an object is start from a point and again after traveling through a distance, it again reached to the same point. In this case, the distance is not zero, but displacement can be zero. If yes, support your answer with an example. Okay, you can give the example of this question. Now the second one, a farmer moved along a boundary of a square field of side 10 meter in 40 seconds. So this is a farmer and this is a square field which is having the side of 10 meter, and the farmer start from here, this point A. Suppose ABCD is a square, na? So a farmer start from the point A and move along the boundary of this square field which having the side of 10 meter, and it moves along a boundary of the square field of side 10 meter in 40 seconds. So he start from here, this point A, and it can move a distance of which is equal to the perimeter of the square in 40 seconds. Okay, he start from here 10 meter. He move A to B 10 meter and B to C 10 meter, C to D 10 meter and D to A 10 meter. It means the distance traveled by the farmer is the perimeter of the square. And we know the perimeter of the square is 4 into side. So what is the distance traveled by the farmer is the 4 into 10, it is 40 meter. It means farmer can travel the 40 meter distance in 40 seconds. It is given in the question. Now, what will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds? Okay. Now, in 2 minutes 20 seconds, 2 minutes 20 seconds. First, we have to convert it into seconds because we know the value in second, that is he travel a path in 40 seconds. So first we should convert this minute and seconds into second. 2 minute means 2 into 60 plus 20, that is 120 plus 20, it will be 140 seconds. Okay, 140 seconds. So we have to find the distance and the displacement of the farmer after 140 seconds. Okay. So how can you find the how many revolution? We can say revolution, or we can say how much how much time the farmer can. Um, Again, it is a farmer can make a round of this field. It means if he start from here and he make a one round of this field in 40 seconds, so how many round he can make of this square field in 140 seconds. So for this you have to divide the total time by the time taken by the farmer to move along the boundary, to move along a boundary. Sorry, again, um, we know that the farmer can okay, so we can say the farmer can moves along a boundary in 40 seconds. So in 40 seconds he can take a one round of this field. So how many rounds he can take in 140 seconds? What should we do? We should divide the total time by the time taken by the farmer to revolve the field in, to revolve, to moves along the boundary. Again, okay. बोलने में थोड़ा सा प्रॉब्लम हो रही है कि अगर आपको पता है कि एक चक्कर लगाने में उसको कितना टाइम लगता है, तो कितने चक्कर वो लगाएगा निकालने के लिए आप क्या करोगे, टोटल टाइम को एक चक्कर के टाइम से डिवाइड कर दोगे. ओके, सो इट मीन्स द टोटल टाइम टेकन कैन बी डिवाइडेड बाय the time taken by the farmer to revolve around the boundary one time. Okay, now the number of revolution of the farmer is I have to turn the page. Number of revolution of farmer is equal to total time, that is 140 seconds, divided by 40 seconds. It will be 7 upon 2 means 3.5. Okay, so how many revolution he will take in 140 seconds? He will take 3.5 round. It means if we start from here, he moves along the boundary after traveling a 3 rounds, a complete 3 rounds. 3.5 round means after traveling a 3 rounds he will be there in half round, है ना. यहाँ से शुरू किया, 3 चक्कर पूरे किए, और 3 चक्कर के बाद आधा चक्कर मीन्स now he is here. So what is the distance traveled by the farmer? Distance is the actual path traveled by the farmer. Then what is the actual path? We know that the perimeter of the square field is 40 meter. So in 3.5 round, what is the actual distance covered by him? It will be perimeter multiplied with the 3.5. And what is about the displacement? We know that the displacement is the shortest distance between the A and a B. This is the shortest distance between these 2 points A and, sorry, not the B, it is C. So the shortest distance between the A and a C is the diagonal of this square. So it means we have to find the diagonal of this square. And this diagonal is the displacement of the farmer after 3.5 rounds. Okay, so we can find the distance and the displacement of the farmer. First we are going to find the distance. I'm again preparing a figure for you so that you can easily understand with the help of this figure. So we will write the distance traveled by the farmer. Traveled by the farmer is equal to perimeter multiplied with the 7 upon 2. It will be 140 meter. This is our distance. Okay, and what is about the displacement? Displacement, since we know that displacement is the shortest distance, displacement is equal to the length AC. And how can we find the length of AC? According to the Pythagoras theorem, we know that AC square is equal to AB square plus BC square. This is a square field. So we can find this length by using the Pythagoras theorem of mathematics. So AC square is equal to AB is how much? It is 10. It is also 10. So it will be 100 plus 100. It is 200. Now, this is the AC square and you have to find the AC, the length of AC. So you have to square root of this 200. It will be 2 root 10 meter, or we can put the value, sorry, it is 10 root 2. Actually we factorize the 200, 2 into 10 into 10, or you can even do the you can even do the prime factors of this 200. So it will be 2 into 2 into 2 into 2 into 5 into 5. So by pairing these numbers we will find the 10 root 2 meter. We can also put the value of root 2. It is 1.414. So it is 14.14 meter. So this is the displacement of the farmer. Now further, the uniform and non-uniform motion. Okay, uniform. Okay, one last question. I just forget to explain. The last question is, which of the following is true or for the displacement? It cannot be zero. Yeah, I have already explained you that displacement can be zero. In case of this type of motion or this type of motion, the displacement can be zero. Its magnitude is greater than the distance traveled by the object. No, its magnitude can be equal to the distance traveled or it can be less than the distance traveled. Okay, now again, the uniform and non-uniform motion. So, what is the uniform and non-uniform motion? Okay, just try to understand it. Suppose this is a moving object and it start from A, this point A. An object start from here, and in 1 second, suppose the object travel the distance of 5 meter in a straight line. It can be straight line, it can be a circular path, it can be anything, because it is motion. Motion is the vector. Sorry, it is not the vector, it is a scalar quantity. So again, in next 1 second, it come to the point C, which is also 5 meter apart from B. Again, from C, this object come to the point T in 1 second in 5 meter. So in this case, the object is traveling the equal distance in equal interval of time. So this type of motion in which the object travel the equal distance in equal interval of time, we will say this motion is uniform motion. Okay, so here the direction is not necessary to mention, because direction is we always represent the direction for the vector quantity and motion is a scalar quantity. So this is the uniform motion. And what is about the non-uniform motion? Suppose the object start from the point A and it travel 5 meters in 1 second and come to the point B, and in next 1 second suppose it travel a distance of 7 meter. It can be any value. Or in next 1 second suppose it travel a distance of 6 meter. So in this case, the distance traveled by the object is not equally in every 1 second. So it means the unequal distance object travel in equal interval of time. This time interval can be any value. It can be 1 second. It can be, even though it can be 1 minute. It can be 1 hour. So it doesn't matter how much you are taking the time, but the time should be equal. It means if you are taking the 1 second, the time should be 1 second for every distance. So for first 1 second, it travel a distance of 5 meter. In next 1 second, it travel a distance of 7 meter. In next 1 second, 6 meter. So in case the object is traveling unequal distance in equal interval of time. So this type of motion of a body is called the non-uniform motion. Okay. So these are the uniform and non-uniform motion. And you know what is a speed? Speed. Speed is the Distance upon time. You know the formula of the speed? It is distance divided by time. It means how much distance you travel in unit time is called the speed. So unit time is in 1 second, in 1 minute, or in 1 hour. Unit means one. So the distance traveled by a moving body in unit time is called the speed. And what is the unit of SI unit of speed? The SI unit of speed is meter per second. This is the SI unit. But this unit is very small. So for higher values, we use the kilometer per hour. Kilometer per hour. Otherwise, the SI unit of speed is meter per second. Okay, now if you want to convert the meter per second into kilometer per hour, suppose we have the value, it is 36, no, it is 30 meter per second, and you want to convert it into kilometer per hour. What should you do? First, for the conversion of meter into kilometer, we have to divide it by 1000. Okay, 30 meter divided by 1000, it will convert into kilometer. And upon second, and you want to convert the second into hours. So how can you convert the second into the hours? By dividing second from 16 to 60, because in 1 hour 16 to 60 seconds is there. So by dividing it by 16 to 60, or you can write it like this, multiply with the 1 upon 16 to 60, because you have to divide it by 60 upon 16 to 60. And by reciprocal of this value, we will find 30 into 60 into 60 upon 1000. Okay, now I'm not going to calculate 30 with this value. I'm going to explain only what value can you multiply with any numerical value of meter per second to convert it into kilometer per hour. Here 0 cancel with a 0, and we can get it by the 2 5s are 10, and 2 3s are 6. So it is 30 into 6 3s are 18 upon 5. It means by multiplying any value with the 18 upon 5, it is not necessary that you always divide it by 1000 and multiply it with the 16 to 60. You can easily multiply it by 18 upon 5. So if you multiply 30 with 18 upon 5, you can easily convert it into kilometer per hour. Okay, so it will be 108. Okay, it is kilometer per hour. So I think it is very easy to remember that if you want to convert the meter per second into kilometer per hour, you should multiply the value with 18 upon 5. Okay. Okay, now again, if you want to convert the kilometer per hour into meter per second, what should you do? Because in some questions, the value will be kilometer per hour, and it can be asked that convert into meter per second, then what will you do? In this case, suppose this is a value. I'm taking the value y. Okay, it can be any numerical value, and you want to convert it into kilometer per hour. Sorry, meter per second. Y kilometer per hour. You know that in 1 kilometer there is 1000 meter. So we can write it like y into 1000 upon hours. If you want to convert the hours into second, what will you do? Multiply 60 into 60. We can divide the for conversion of the hours into seconds. We know that 1 hour is equal to 16 to 60 seconds. So upon hours, नीचे है ना hours, तो नीचे है का मतलब है कि आपने upon वाली वैल्यू को 16 to 60 से मल्टीप्लाई कर दिया सेकेंड्स में कन्वर्ट करने के लिए. तो इफ़ यू वांट टू कैलकुलेट इट, 2 5s are 10, 2 3s are 6, it will be y into 5/18. So it's very easy. If you want to convert any value into meter per second, you have to multiply it with the 5/18. If you multiply any numerical value which is given in kilometer per hour with 5/18, if you're going to multiply any numerical value to 5/18, you can convert it into meter per second. Okay, so these are the conversion of speed meter per second into kilometer per hour and kilometer per hour into meter per second. Okay, again, what is the average speed? Average speed. Average speed is the total distance traveled by the moving body upon the total time taken to cover that distance. Total time. It means in case if you want to find the average speed, you should know the total distance and the total time taken by the body. For example, this is also example of NCERT book. Example 8.1. An object travels 16 meter. This is a distance traveled by a body. Example, which is 16 meter. In 4 seconds, the time taken by the moving body is 4 seconds to travel the distance of 16 meter. And then another 16 meter in 2 seconds. Now again the distance traveled by the body is 16 meter and the time taken by the body to cover the distance is 2 seconds. So if you want to find the average speed, you should know the total distance which is 16 plus 16 is equal to 32 meter, and the total time, it is 4 plus 2, 6 seconds. Okay, so you know the value of total distance and the total time, so easily you can find the value of average speed. It is 32 upon 6. It will be 6 5 is 30.66, sorry, not 6, 3 है ना, 6 5 is 30, 20, 26 3 is 18, then again 20, so it will be 5.33 meter per second. So this is a very simple question, because in case we have distance and the total time. Or how can you solve the question if you have given the speed and the time? Okay, there is an example. This is not from NCERT book. I am taking randomly. Suppose I explained you, suppose someone asks you the speed of a body is 40 meter per second for the time suppose 4 seconds. Okay, so a moving body has a speed of 40 meter per second for 4 seconds. Now again its speed is going to be changes, and now its speed is 50 meter per second for the time is 2 seconds. Okay, for the next 2 seconds the speed of the body is 50 meter per second. Now if someone asks you, I ask you, how can you find the average speed of the body? So with the help of this speed, you can't find the value of average speed. First you have to find the total distance. Okay, because we know the formula of the average speed, total distance upon total time. So first you have to find the distance and then the time, and then you can find the average speed. So in case if the speed is given for any question, first you have to find the distance. We know that according to the formula, the distance is equal to speed multiplied with the time. है ना? Speed is equal to distance upon time. Speed is equal to distance upon time. So distance will be speed multiplied with the time. So in first case, distance is how much? It is 40 into 4. It is 160 meter. And the time is how much? Time is 4 seconds. Or for the second case, the distance is equal to speed is 50 and the time is 2. So it is 100 meter. And the time is how much? Time is 2 seconds. So now you calculate the distance and the time. So you can easily calculate the total distance and the total time. Total distance is 160 plus 100. It is 260 meter. And the total time is equal to 4 plus 2. It is 6 seconds. So what will be the average speed of the body? It will be 260 divided by 6. So by calculating this value, you can find the average speed of the body. Okay, we will continue the revision of these chapters in next videos. Okay, till then, bye.